All right, we're talking about Noid light testing. And again, a Noid light is a light bulb basically that you're plugging into the injector harness. A Noid light does not check the injector itself. It just checks the wiring and the driver. You're looking for control. So one of the things that you need, or two of the things that you need for a Noid light to function, is you need a power and you need a ground. If you have both of those, the Noid light's going to light. So I have a Noid light section in my book, section 18 is where we are, and we're talking about Noid light testing. To follow this properly, what I want you to understand is that we're dealing with a no-clicking, single-cylinder misfire, engine still runs. When we talk about these variables in here, which is the Noid light flashes, the Noid light doesn't flash, the Noid light stays lit all the time. These are the ones that we are dealing with. With these variables, I want you to understand that I'm limiting this to a single cylinder misfire, but the engine still runs. And the reason behind that, when we're talking about Noid light doesn't flash, Noid light flashes, Noid light stays lit all the time, I don't want to talk about cam and crank sensor inputs for this. So of course, if the Noid light doesn't flash and the car is a no start, you could have a crank sensor problem, cam sensor problem. And I wanted to just focus really right now on just the injector itself. So you got a feed to the injector, the winding for the injector, the control wire, and the computer. And I want to, in this section, focus on just this. I don't really want to get into the inputs here. We'll do that later. So again, understanding that we're talking about single cylinder misfires here when we're doing Noid light testing. Okay? Starting with the Noid light doesn't flash. If the Noid light doesn't flash, again, what we're doing is we're disconnecting the fuel injector, which is this piece, and what we are doing is we are installing a light bulb in place of the fuel injector. And we're looking for that bulb to flash. And what we need is a good power, so the feed has to be good. And we're looking for a good control, which is, in this case, ground side switched. And if the Noid light doesn't flash, so starting here, we're looking for, number one, check for power to the injector. And that's a simple check. You could use a test light, you could use a voltmeter, check this side, make sure you have 12 volts. The other option for this, with the Noid light not flashing, single cylinder misfire, is you want to check this control wire for opens. If that control wire is open, this Noid light is not going to flash. And then one more for a Noid light not flashing would be the computer driver. So now we're talking about this transistor inside the computer, which is a ground side switched component. We have to check that driver as well. And so the process that I would take you through with this would be verify your power first. Okay? Put our diagram back up there. We got a fuse, we have our Noid light, we have our computer. Check your power. So you're here with the voltmeter. You read 12 volts. Now, a lot of the flow charts are going to have you disconnect the computer, disconnect the harness, measure resistance. You can do that. I prefer using my voltmeter. At this point, I probably just have the key on. Maybe the car's still running. All I'm going to do is take a voltage reading at the computer on that wire, that same control wire that goes to the injector. If I read 0 volts at the computer, take a measurement here. Of course, you want to have a good Noid light. This should be 12 here with the circuit off. This driver open. If you have just the key on, engine off, you should have 12 right here at this point with a good bulb. Remember, no current flow, no voltage drop. If that circuit's open, that 12 volts is going to come through from the feed side It's going to go through the bulb element and look for a ground. There isn't one. So equal potential, both sides. I got 12 here, I got 12 here. Go to the computer. If you have 0 on that wire, you're done. You have an open in that circuit. Find your open. If you have 12 volts in this step, it is not an open in the wire, and now our focus goes to the computer driver. Focus is now on this. So when we're talking about computer driver problems, there's some other things to think about. And I don't have it on this page. I have it later in here when we do voltage testing. I mentioned the other issues with computer driver problems. Before you would put a computer in this car, now we have to think about what inputs this computer needs to function. And so you're talking about input problems you would want to check. And then the other thing in here is a severe misfire. And with the severe misfire, what OBD2 systems will do, and this can really throw you for a loop, with a severe misfire, an OBD computer will shut the injector driver off. And what that does is it protects the catalytic converter from too much fuel. Obviously, with a cylinder misfire, think about it. Let's say one of the coils stops firing and you have no spark causing your misfire. So what you have is raw fuel being pumped down into the tailpipe and into the cat. So what the computer will do with that single cylinder misfire is it'll shut the injector off. So let's say in that process you decided to start your diagnosis by checking injection pulse. You didn't bother checking spark first. Maybe it was a coil overplug and it was a difficult coil to get to. So you started at the injector because it was easier to get to. That just might have been your starting point. You put a Noid light in that cylinder, car's running, misfire, and you notice the Noid light's not flashing. So that's where we are. Noid light doesn't flash. And you go through your motions, you start checking things, you got good voltage, you got good 12 volt at the computer, and you start focusing on a computer and you think you need a computer, but when in actuality what you have is a coil that's not firing or a coil that's arcing to ground. The computer's protecting itself. So how do we avoid that situation? What you need to understand about the computer shutting down the driver is it will not do it on initial startup. Doesn't matter how severe the misfire is. If you start the car on initial startup, if that injector's firing and then shuts off a few seconds later, that is an intentional shutdown. Okay? So how do we know? Is it a driver problem that we do actually have an injector problem, or is the computer intentionally shutting it down? Well, there's two things. One, you should have put a scanner on it in the first place and saw that you had a misfire trouble code, and that should be on your mind immediately that if you see no injection pulse, it might be intentional. But the second one is simply shut the car off, Noid light's still installed, restart the car, and see if it lights. See if it starts flashing for a few seconds. It might be 5-10 seconds that the computer will get everything back to where it should be till it recognizes the misfire again, then shuts that injector off. Keep that in mind. I have that in here. It's in a later section in this chapter when we do voltage tests and scope tests on injectors. It's in there. That's why it's not right here, but I wanted to mention it when we're talking about a Noid light that doesn't flash. Okay. Another thing that could happen when I mentioned input problems, that wouldn't be typical, but there's one design I'm thinking about, which is the Nissan optical distributor. They're known for oil to get into the drive plate, and what you essentially had was an LED, and you had a photo cell, and these two guys would have a plate that would rotate between. And this plate, if you're looking at it from a top view, would have these slots cut out in it. And each of these slots would be a cylinder ID. And these were known for oil from a worn out distributor shaft to accumulate and cover it wasn't uncommon to cover one of the slots. And what would happen is every time this thing would rotate, and this one cylinder with oil blocking that drive plate, what that would do is this LED would never make, the light from the LED would never make it to the photocell, and it would never trigger the transistor. So you would not have injection pulse on that one cylinder. You would also not have spark on that one cylinder. Is that a variable for a Noid light that doesn't flash? Yes, that's why I'm mentioning input problems, severe misfire. And again, it's not here because it's later in the book, but I'm not doing that right now. I'm just talking about the Noid light. So we added that to this. Just don't be in a rush to change the engine computer when you have no injection pulse. There's some other variables you got to think about. Lastly would be, when we say PCM driver problems, input problems, severe misfire, and then of course powers and grounds. We never put computers in cars without checking powers and grounds. What are the chances though, let's say you do have a driver problem, what are the chances of it being a power or ground problem if, let's say you have a 6-cylinder engine and all the other 5 are working fine, but the one isn't? Slim to none. It being a power or ground problem, but you should still go through the motions. Okay, the next one, Noid light flashes. Again, what we're dealing with, I want to emphasize this, single cylinder misfire, the engine still runs. Okay, if you plug a Noid light into that cylinder that's misfiring, no clicking, maybe as noted by your sound test that you did with your screwdriver up to your ear, no clicking from that injector. So we're not talking about spark here. We're going to stay on injection. Noid light flashes. You got a bad driver. Sorry, you got a bad injector. Okay? It's that simple. There is a variable to that. I don't really like the Noid light as far as injection tests go. You guys can attest to that watching my videos. I'm using a scope always when I'm doing these. I don't use the Noid light often, but a lot of people do, and a lot of people don't have access to a scope, so this is in here for them. But a bad injector, but in rare cases, a weak driver could still be an issue. And the reason behind that is amperage. If you've ever measured the current flow of a Noid light, you're talking about 100 to 200 milliamps of current that a Noid light carries. A typical, as we learned yesterday, a typical saturated switch fuel injector draws about, in comparison, about 1,000 milliamps or 1 amp of current. If you're talking about a peak and hold injector, you're talking about 4,000 milliamps on the peak, right, and 1,000 milliamps on the hold, or 4 amps on the peak, 1 amp on the hold. Notice how much less the Noid light amperage is. Have I ever seen that? No. I've never seen this where you could have a Noid light that flashes and have a bad driver, but in theory it is possible that driver can't handle the current that the injector would normally draw, but it can flash the bulb. So again, this is scope here to catch this the right way. I've read about this. I included it so you understand that's a variable. I have never seen that. What I've seen with fuel injector drivers is they either work or they don't. I've never seen one going bad, which is what this would be. It functions, it just doesn't function right. It can carry the current flow for the Noid light, but can't carry the current flow for the injector. It's a theory issue. It can happen, but I've never seen it. So it's there. Noid light flashes, let's just say bad injector. Okay, single cylinder miss, plug a Noid light in. Of course you verified good spark, good compression. That's not what we're talking about here. We're just staying with the injection. Lastly, Noid light stays lit all the time. So you put your Noid light in this diagram, and it should be flashing on and off, but it is actually lit constantly. Now, one of the things about that you need to understand is the symptoms of this last one. Of course, it's a misfire. No question about it, right? This is a misfire, this is a misfire, this is a misfire. But the symptoms with this last one are going to be different. You're going to have extremely long crank times. Okay? And the reason for that is if you plug a Noid light into this circuit like you've done here, what that means is that injector's on all the time. It has power and it has a ground all the time. How rich is that engine going to be running if the injector is spraying all the time? I have a video on that. It was a case study on a 2000 Dodge Caravan where they short the ground in the harness where that circuit's on all the time. And I'm not using a Noid light in that video, but you have to check it out because just to see the symptoms with that, you can hear the engine cranking. It cranks for a long period of time. And then surprisingly, you have huge clouds of white smoke coming out of the tailpipe. And a lot of people would take argument with that because we've all been taught that when an engine runs rich, the smoke is black. And my argument to that is, well, first of all, watch the video. You can see it. I'll have to show it to you guys. I'll show you in a minute. But the other thing is, it's not going to be black if you're not burning it. And there is absolutely zero flame going on in that cylinder. That plug is soaking wet. There is no flame going on. You are pumping literally raw fuel down the tailpipe, and it's just steaming in the exhaust. It is white smoke. You would swear that it's a head gasket. I was at one of my garages doing a job. Customer brings a car in. I'm working on a different car. Clouds of white smoke coming out of the tailpipe. So he says to the garage owner, I'm just eavesdropping. He says, I got a bad head gasket. Can you check it out and make sure? That's what I was told. And I knew it wasn't immediately. And it was by the smell of the smoke coming out of the tailpipe. I mean, it smells like raw gas. You would not want to put a match to that one. It would be, you would have a problem. So symptoms, again, if that Noid light stays lit all the time, you have a constant spray from that injector, severe rich conditions. You know, forget about everything else. Don't worry about your O2s and your fuel trim and none of that stuff at this point. Focus on your fuel pressure. Put a gauge on it, right? What do you think is going to happen with, say, rest pressure? When you start the car, shut it off, what's the gauge going to do immediately? There is no rest pressure. It's an immediate drop, right? So we start addressing it probably that way. But in any case, that's what we have. Using a Noid light, what can you do? What's a quick test? Take this. Let's put our Noid light back in there. It's lit all the time. Our options, you need to understand, is either a short to ground in the control wire, which is this wire right here, or we have a shorted driver in the computer. Those are your two options for the Noid light staying lit all the time. So what I do is I will turn the key off and I will disconnect the computer, turn the key back on. If my Noid light is still lit, computer's unplugged, your problem is definitely a short to ground in the control wire. Computer is isolated, it's out of the picture, you have it unplugged, you turn the key back on, that Noid light stays lit, you have a short to ground in the control wire, go find it. If you disconnect the computer, turn the key back on, and the light is out, your focus would now be at the computer. So if you unplug the computer and this Noid light goes out, turn the key back on, it's not going to be a short to ground. Your focus is now here. But I want to warn you of something, and this is why I talked about the ASD relays on Chrysler so much. And Chrysler isn't the only manufacturer that does this. You need to understand that power to this circuit is controlled by a relay on some vehicles. Chrysler uses an ASD. There's other manufacturers that use a relay to control power to the injectors. And And it isn't just the injectors, it would be injectors, ignition coils, fuel pumps, some other circuits. We'll just pick on Chrysler, ASD. Understand that the ASD relay is controlled by the engine computer. So if you weren't paying attention and you're doing what I'm teaching you here, and you unplug the computer and your light is now out, so your focus, you said, well, I had to have a sorted driver because that's what was making my light stay lit. You forgot to check to make sure you still had 12 volts on this fuse. Because if you unplug the computer, you also eliminate the ASD relay from turning on, and you also are going to eliminate voltage from coming on this circuit, so the light's going to go out whether or not you had a short to ground here or a shorted driver here. It's not going to matter. The test now just had a curveball thrown at it. So that's why I have right here, when you're doing this and you unplug the computer down here, unplug the computer, key on engine off, the Noid light goes out, you got a shorted driver, right? If Noid light stays lit, short to ground on the control wire. That's very easy. That's pretty straightforward. But that's why I have this in bold print or capital letters and 7 exclamation points. Do you understand that we want to make sure in this test, if we're unplugging the computer and we're relying on a Noid light, unplug the computer, make sure the injector still has power before you condemn the computer. And that's what I'm talking about right here. Some systems will not have power to the injectors. Key on, engine off. The PCM must have an RPM signal to energize the circuit, so the above testing must be altered. So let's alter the above testing real quick. This is where I prefer my test light. Same setup. We've already addressed that the Noid light stays lit all the time. Right here, we're doing this. You got a Noid light in there, it stays lit all the time. Get your Noid light out of the picture now. Unplug that circuit. So what we have is an empty spot here for our injector connector. Take your test light to battery positive. We're not using a Noid light now. I'm going to use a test light to battery positive. The car is running still, let's say. Of course, my test light is going to be lit constantly. I'm going to do the same checks that I did previously, but I'm going to use my test light. I like this one better because when I get to the point where I'm going to unplug the computer, turn the key back on, I don't have to rely on the computer controlling the power side to keep the light lit. I'm using my test light to battery positive, and that eliminates that variable down here. Put your test light to battery positive and unplug the computer. If your test light's still lit, you definitely have a short to ground in the control wire. If your test light goes out, you definitely have a shorted driver. There's no variable with the power feed side because we're using our own power feed. All right, addressing what we just talked about with short to ground in the harness on a fuel injector. So we're talking about the Noid light staying lit all the time, and we're watching the video that I have on the stock open fuel injector. And about the 6-minute, 20-second mark, I'm talking about that test where I'm using the test light. The last thing I talked about in our Noid light test was putting a test light on that circuit and why we don't want to do that with the engine off, where we wanted the engine running because we wanted that ASD circuit energized. So if you think about the circuit we're dealing with, we have a control wire and a computer, and what I did in that is I had the computer unplugged and I pulled the wire out, and then I plugged the computer back in. So just picture that right there. And we're putting a test light connected to battery positive, and our test light was lit. And I'm saying in the video that you don't want to do that test with the engine off in this case, because this circuit, let's draw the rest of it now, so that we have a fuel injector, and this injector gets power from an ASD relay. But you have to understand that there are other injectors that are going to come off this same circuit. In this engine, there's 6 of them, right? So we have other branches for the other injectors. You're also going to have, this is the load side of the ASD relay. So load side of the ASD, when we're talking about a relay, we're talking about this side right? This goes to battery positive. That's hot all the time. I'm not talking about the control side here. That's what the computer controls. That's what makes the magnetic field. Load side of this relay is where we are. ASD, this comes down to the fuel pump. Fuel pump's on that circuit too, isn't it? What else is on that circuit? We have an O2 heater is on that circuit. So here's your O2 heater, and it goes straight to ground. What else is on that? Injectors, fuel pump, O2 heater, ignition coils on there too. We don't need to draw that. The fuel pump's good enough, but watch this. With the engine off, this relay is open. So there is no power on this section right in here. There is no voltage and pressure here. It's not there. 0 volts. If I put a test light like I have right here connected, I have a test light right here. If I put this test light connected to battery positive with the engine off, this is open. What's going to happen is it's going to find a ground through this injector and through the fuel pump. And guess what's going to happen? A light's going to light. It might be a little bit dim because it's got to go through the injector, which is some resistance. But that's why I said in this video, you have to have the engine running. You have to think what you're doing when you're doing tests like this, because with the engine running, this switch is closed now, and we're going to have 12 volts on this side, aren't we? So I'm putting pressure this way, and if that light is lighting, it's because of a short to ground, not a back feed through the fuel pump, because you have this relay off. So I want to be clear on that. If you're doing this kind of testing, you got to think about what you're doing. Okay, question I just had was, can we unplug the relay and eliminate that problem? And the answer is no. This is hardwired, and there is no separating this splice, which is right here, that runs down to this fuel pump. So unplugging the relay won't help. The key with this is, again, just making sure that when you're doing this test over here, and you're using a test light connected to ground, and you're saying, well, that test light's lit, so I'm saying I have a short to ground in the harness, not a computer issue, that you just want to make sure the car's running. If the car's running, in this case, in our case, we know for a fact that we have 12 volts over here. Now, there's other variables where the car isn't running and things like that, but on a Chrysler, you guys got to remember, you can put a scan tool on the car and command that ASD relay to turn on. You don't need the car running. You just need to make sure that ASD circuit's powered up. You know, the other option too, guys, would be as simple as unplugging this injector and get that out of the picture, right? And that would eliminate any back feeding type problems. But you have to understand the vehicle we were working on. These would be, you know, this is the feed line for all of my injectors, and you have to understand that this is covered. The intake manifold covers it. I can't get to that injector to unplug it. So of course, unplugging the injector would eliminate any backfeeding type problem, but you can't always do it. You have to think about what you're doing. And in that video, again, starting around the 620 mark, that's why I wanted the vehicle running. And when I said with the key on, engine off, when this light was lit, it was, with my test light lit and the key on, engine off, I said in the video that it was not a valid test. And that's because I'm thinking about the back feed that I was mentioning before. And that back feed would be going this way through the coil of the injector, through the fuel pump. Why the fuel pump? Because fuel pump brush DC, brush type electric motor, when they're not spinning, there's basically no resistance through that electric motor. It is a short to ground, if you want to call it that. It's not really, but if you put a test light on that, it's going to light. You put a test light to battery positive anywhere on this feed side of the circuit, test light to B+, it's going to light, and it's going to light through this fuel pump. Granted, you'll have some through the O2 heater circuit as well, but that test light's going to light. All right, that's it. Just want to be clear on that. All right, what I said at this point in this video is that's not a short to ground in the circuit with that light lit like it is right now. Remember, there still is a short to ground on this car. That isn't a valid test with the key off is what I'm trying to emphasize. Yes, there still is a short to ground in our harness, and my light would be lit just like it's showing in this picture, but understand that you don't want to do that test to make a definitive call on a short to ground in the harness because of that back feeding situation.